You can all hear me well, right? All right, cool. So my name is Anil Gursel. I work at PayPal in the infrastructure team. So we basically work with other product development teams to help them build performant and resilient applications. So I'm a contributor of the Scoops project that was open sourced by PayPal, and I'm going to be talking about it in the talk as well. So today I'm going to be talking about the journey from monoliths to microservices. So what problems might, I'm going to be talking about the journey from monoliths to microservices and what problems might be encountered and some solves and practices around that. And I'm going to be emphasizing the standardization across the services. And finally, I'm going to be introducing you the Scoops project. So you have a monolith and you decide to split it to many services. I mean, depending on the company size, you might have like 10, hundreds, or I don't know, even thousands, depending on the size of the company. So I think it was around 2005 or so, PayPal still had just single application, like CGI application on C++. Just building that was taking like more than an hour, as far as I heard. So around 2005 or so, the PayPal decided to split the monolith and created more services. At the time, they were not necessarily called microservices in the 2 days that we understand in terms of isolation, etc., but more service-oriented. But in the last few years, 5, 6 years or so, they're more like microservices in the way that we understand them. So today, after 10 years or so, I do not know how many services are there. It's hundreds, basically, 300, 400, or around that range, basically. So when you move to microservices, you gain a lot of things, like, especially in large companies, you have many teams under different organizations. Teams are not co-located, not even in the same time zone, and all that stuff. So when you move to microservices, you basically gain independence. So each team can deliver their stuff based on their sprint life cycles and based on their sprint life cycles and at their own pace, basically. And they don't have to wait for other teams. They can just deliver whatever they want, and it's basically going to be a lot faster for them. And they can, based on the business scenario, business case, or the scenario, they can basically select whatever technology they want. And whenever they need to evolve it, it's a lot easier to move. However, while moving that, another thing you gain is the complexity. So while there was only one single application that you could have apply some rules, etc., that you have to monitor, now there is hundreds of moving parts all around, and your ecosystem gets quite complicated. And along with that, now you have all the network hubs. The latency will be a problem for you. And plus, also there's going to be a lot of inconsistent services out there. So let's discuss about some of the issues, some of these issues. So latency. So I mean, this is just a sample, but I've seen a lot worse scenarios than this. So assume that everything is REST over here over HTTP. You get an HTTP request, goes through a standard gateway, and then needs to talk to service A, right? Because of zoning requirements, etc. There's a proxy, goes to the proxy, then service. Guess what? The service A turns out to be just an orchestrator service. When you have too many services around, that seems to be an emergent thing as well. Some services don't do anything but just call other services and do some orchestration. And then it calls service B, C, etc. Finally, it gets reaches to the data store and then gets the data. So the problem with this is, I mean, the latency increases, but not only it increases, it becomes indeterministic as well. So, assume that all these services are JVM based, right? Any one of them might be doing a GC at any time. The network might be slow. Any application might be having a memory issue or a CPU spike, etc. So, and if you look at the histograms over there, what's perceived by the gateway is basically the latency is the distribution. The distribution is a lot wider over there. So you will try to reach your SLA in 100 milliseconds, yes, but when you want to do that in 99 percentile, it's going to be when you have too many services and too many network hubs, it's going to be harder to reach that. So, I mean, when you are moving to microservices, I mean, I understand, especially people who have had enough pain with the the monoliths in the past want to create more fine-grained services, but just keep the latency in mind all the time. So another one is this service boundaries. So you want to create services, but should I be creating 2 services, or is it actually 3 services? How should I split that, right? And that's not an easy solution all the time. And actually, most of the time, you start with something, but later on, 3 months down the line, you realize that, oh, I should have created 3, but oh, it's too fine-grained actually. I wish I hadn't separated it that much. So it becomes an important issue as well. And the other one is the scaling. So when we say scaling, the very first thing comes into mind is horizontal scaling, where you add more nodes, basically, and which is great, and we should be able to be horizontally scalable. But I mean, when your number of requests that you need to handle reaches to billions, sometimes like the number of nodes also, like when you try to horizontal scale, it goes hundreds. I even know one pool which has more than 1,000 nodes. So when you have 1,000 nodes, basically, then the maintenance becomes a problem as well. So you need to, whenever you need to roll a new version of the code, now you need to roll it to the 1,000 VMs, and a security patch, you need to roll it to everyone, all the nodes. And the other problem is that the other problem is that you may not be. I mean, it also like not something very obvious is that it puts some pressure on the network as well. Just think about the load balancer. It needs to check 1,000 nodes right now instead of like just checking 100 nodes for the health check or something like that. And so for that reason, I mean, horizontal scaling is great, but we should also be able to like vertically scale. So whatever technology you choose for your microservice, it should be, especially with the Moore's law not take in effect anymore. The CPUs are with like 64, 128 cores. We should be able to, whatever technology you choose, should be able to utilize the new CPU architectures, basically. And also, nowadays when we say microservices, most of the time people think about the stateless services, but the stateful services are getting some traction as well. And when nodes talking among each other, and if they're chatty, I mean, you may not be able to, when you grow above some certain point, like maybe 100 or 200 nodes, the performance might be degrading as well in that case. And when a new node joins to the cluster, etc., you might need to do some shuffling. Those operations will be a lot more complicated. All right, the other issue is like we said that there used to be one application out there, but now there is like 100 applications out there. And each one of them is owned by different teams and delivering stuff at their own pace. And any team might be delivering, I mean, at any time, a team might be delivering a new version of their code. Whenever they delivered a new version of their service, basically, it might have some problems, there might be some slowness, they might be breaking some functionality, or if not rolling out the new version, there might be some problem might be going on in the network. So, I mean, there is a need for resiliency, even more need for resiliency when you have microservices, because there are a lot more moving parts and a lot more failure points, pretty much. And when you have all these distributed teams owning different teams, now you have a set of like inconsistent services, and which I'm going to be talking about standardization a little more later in the slides. So let's discuss about some of the practices to alleviate some of the problems. So a standard deployment is, if you have a service A and service B, I mean, the standard deployment model is like service A has its own pool and service B has its own pool, right? And then if a request comes in, goes to the load balancer, and then in a round-robin fashion selects one of the nodes, and if a service A nodes, and if service A needs to talk to service B as well, it needs to go to the load balancer, and then load balancer again selects one of the nodes. So it has to jump over the network. So to optimize this in the industry, some people follow joint deployments, like basically co-locating the services that are communicating quite a bit together, right? So what happens with this is if service A and service B talking among each other quite a bit, you deploy them together on the same VM. So in that case, when a request comes in, it goes to the load balancer, selects one of the service A nodes, but once service A needs to move to service B, it doesn't have to jump through the network anymore, so it's on the same VM. It can be TCP connection, or you might be doing something else like Aaron, etc. But it's on the same VM, so it's some optimization. So the downside of this, though, is now your deployment model gets a little bit more complicated. And service B might not be exclusively used by service A. So service B might be used by service D as well, and you need to deploy it there as well. So, and Reactive Manifesto was published in, I believe, in 2014. So, I mean, we should be all reading that and following what they are suggesting. But basically, every application we build should be responsive, and application needs to be having some upper bounds for the responsiveness, deterministic upper bounds, so that the failures can be detected a lot easier. And as we discussed, like, if anything might be failing, right? And when a failure happens in any downstream services or any part of the ecosystem, we should contain that, and we should not allow the failures to be cascading. And whenever the workload spikes, we should be able to handle that and keep being responsive. Like, we need to be elastic. So to be able to be responsive, resilient, and elastic, so the basic building block is building applications, building message-driven applications. So the application that we build and the communication across applications should be message-driven. So we discussed about resilience, and when you have one of the standard ways of reaching resilience is using circuit breakers, like Netflix Historics or Akka circuit breaker, right? It gets especially important when you have multi-generational services, and and again, like, anything might be failing in the system, and things will be changing without you even knowing about it. So you should be guarding yourself all the time. And when we discuss about microservices and the communication among them, so still the main interaction among the services is REST. That seems to be still the most common one, but it might not be the best one. So first of all, HTTP is not probably the fastest, and the other thing is it is synchronous. So you make a call and wait for a response. So as the Reactive Manifesto suggests, I mean, we should be, the communication among the services should be message-based, especially like when there is error scenarios, and if you would like to delegate that to another service, I mean, it becomes a lot easier. So it's better like to make the communication across services with some messaging system like Kafka, etc. And some standardization. So what I mean by standardization is, so if I'm debugging a important, like, priority one issue that I need to solve it right now, and I'm suspicious about the 2 downstream services that are causing problems, right? So I should easily be able to go look at their monitoring charts or logs and etc. So if there are like tens of different services or 20 different teams across the company, there should not be 20 different ways of representing the same data, or 20 different ways of collecting the data, or the metrics, basically, right? So I should easily be able to go check their monitoring system, and then understand that what's their response time exactly. If someone says TPM, that should be meaning the same thing across all the applications, basically. And when you collect the metrics, we should be collecting them consistently as well. If I have 2 versions of my same application using different algorithms, to be able to fairly compare them, I should be collecting the metrics consistently for them as well. So the other item is the logging. So if throughout this life cycle of a request, if it jumps over multiple services, first of all, I should be able to correlate them. So I should be able to just see, for that specific request, I should be able to see logs from all the services. But not only that, there is some need for some uniformity of the logs as well. Not every single detailed log, but at least at some point there needs to be some standards across the services. For instance, at PayPal, the requirement is for every REST application, for instance, whenever a request comes in, there needs to be a event needs to be logged with following some strict structure. And the same way, when just before the response is sent back, another event being dropped over there. So basically like the correlation ID, status code, etc. So the benefit of that is when I'm debugging another, and if I need to look at the logs of another application, if it says codes, return code, status code, whatever that is, it shouldn't be meaning different things between them. If it says HTTP status code versus domain specific code, so that helps you while debugging. Basically having a standard over there helps you with that. And apart from that, if there's some uniformity, you can build tools that can generate daily, hourly, etc. reports basically. And another item is security. So, I mean, you cannot say, here is my 5 applications which are super secure, and here is the other 3 not that secure. I mean, you are as strong as your weakest point, right? So every single application needs to be secure and should be following all the security standards. So whether it is like how you initialize your SSL context, or how you load the keys, or which security algorithms you use, etc. So that needs to be standard across the application as well. So whether it is monitoring, logging, or security, so if you have a large organization with many teams, so you should be standardizing this, and it helps. So one way of doing that is you can publish a spec and then ask every single team saying that, hey, you should be following this spec, which will work, of course. But if there are too many teams out there, one of them will be making a mistake while defining those security related features or something. Something will be broken. But the other problem is that you don't want too many people to implement the same thing again and again. So you want to implement it one and let the other people somehow utilize it as well, just for efficiency reasons, basically. So having said that, I'm going to be introducing the Scoops project. So Scoops is written in Scala, 95%. I mean, the rest is Java. And probably 5% comes from the boilerplate. So, so Scoops is based on Akka, Spray, and we support Akka HTTP as well, and nowadays Akka Streams. So Akka is basically a great library, highly asynchronous, highly performant, and especially the hierarchy of the actors basically allows us to implement recovery mechanism in fine-grained manner in different levels, and allows us to implement all the resiliency features. So if you would like to build reactive systems, basically, these are great libraries. But being libraries, though, provides quite a bit of flexibility, but the flexibility comes with some inconsistency. So Scoops project was started to standardize the deployments of Akka applications. So we have quite a bit of Akka applications, how we can deploy them in a standard way. So Scoops provides a very lightweight bootstrap module called Unicomplex. So it basically starts up the actor system and starts all the components in the system. So while doing so, it also defines some lifecycle events like starting up, active, stopping, shutting down, etc. And any actor can basically subscribe for such events, and Unicomplex will be sending those events. So these events basically allow us implementing some hooks during startup and shutdown. So normally, for instance, for actors, you can define a pre-start, pre-init logic over there, but we usually just let it start. We don't wait for it. But from the product development teams, we have been hearing that, hey, I don't want my application to start taking any traffic until I can initialize it and I can make sure that everything is ready, etc. So what Unicomplex basically helps you with is you can, in a configuration file, say that this actor will be involved in the startup process and needs to be giving a confirmation before the system state turns active. So Unicomplex will basically be waiting for all such actors to send a thumbs up to turn the system state to active. So for instance, just to give an example, every PayPal application needs to have a health check endpoint, and the load balancer basically checks, are you up, right? So the health check endpoint basically registers itself to receive lifecycle events. And until all the actors send an active thumbs up message to the Unicomplex, Unicomplex will wait. And once everyone sends a thumbs up, Unicomplex will send the I'm active message to the health check endpoint, and health check will say that, okay, I can take traffic, and load balancer will see that next time it checks and will start sending the traffic. But until then, the app will not be taking any traffic, for instance. And in a similar way, we can implement shutdown hooks as well. You might need to do some cleanups, etc., just before shutting down. So I'm going to be talking about some of the scripts terminology right now. So the first one is listener. So for the folks who are familiar with Spray or Akka HTTP, right? I mean, at the end of the day, this is the Spray listener configurations, right? So normally you do that in the code. You say that http.bind and handle, or in case of Spray, you send an HTTP bind message to the IO actor, and then specify all the configuration over there programmatically, right? So in scripts, when we say listener, it's just a declaration of the this listener settings, basically. In a reference.conf or application.conf, you define how you will be initializing your SSL context, what interfaces you will be binding, port information, etc. So we can basically, as the infrastructure team, I can specify that in a dependency file, and the app teams basically can just use it. And if I change any security related setting or any other setting over there, that's going to be transparent to them. So another thing is the service. So service is nothing but an Akka HTTP route, right? So you code your Akka HTTP route, you use your directives, path, get, extract request, etc., and nothing different over there. Just you're coding against Akka HTTP API. The only difference though is the addition though is, along with implementing your routes, you also specify them in a configuration file called scripts-meta.conf file. So you have the payment route, for instance, and you specified it in the configuration file, and you bind your services to a listener. So what it allows us basically doing is now, by just looking at the configuration in the class path, Unicomplex can now figure out what all the services, what all the routes in the class path are, and knows all the listener configuration. So we basically let application teams don't need to care about how they start or how they bind to a port or how they initialize their listeners. We let Unicomplex do that. So Unicomplex, by just reading the configuration, can figure out, aggregate all the routes, and do bind and handle for you, basically. So, and this basically allows us to start the application in a standard manner across many applications, basically. And we can basically, if any update needs to be done to the listener configuration, we can still manage those in the libraries in the next version without, I mean, of course they will know about it, but without requiring them to do any code change, we will be basically be able to deliver some features. So what it also allows us doing is, so I discussed about the health check endpoint, right? So we deliver that health check endpoint, health check route in a jar file. So I can now just specify my routes in a jar file and specify the scripts meta-conf over there as well. So normally, if I just with the bare Akka HTTP, if I specify the route in a jar file, I would have to ask all the application teams, hey, make sure that you append it to your routes, basically, and then they need to like append all the routes and then pass it to the bind and handle, right? So since I specify things in the configuration, so at this point, all I ask to the application developers is just drop this dependency in your build.spt, that's it. So we basically eliminate all the mistakes being done by, oh, did you append it just after this post or get, or is there a web context over there? So we basically eliminate that kind of potential problems over there as well. And we have something called extension as well. So if you work at a large company, there is always a legacy, basically. I mean, you have to deal with that. So if you are dealing, we need to deal with some non-actor related stuff. So these basically, extensions basically provide us some hooks during startup and shutdown to initialize or clean up and do some initialization and cleanup for non-actor stuff. All right, so we discussed about logging and metrics collection, etc., in a uniform manner. So Scoops provides a request and response pipeline. So this is the Akka HTTP specific version of it. So Akka HTTP is built on top of Akka streams, right? So what Scoops provides is, it allows you to define a bidirectional flow, right? You can define it in a jar or in your application, and then configure it in the application.conf or reference.conf. And Unicomplex, while starting up, will be able to read that and will plug that flow in front of your Scoops service. So you basically, as the infrastructure team, what I can do is I can define a flow and set it as a default flow in the configuration. And just make sure that all the application teams have the dependency that has all this configuration and flow definition in their build.spt. All of a sudden, they will just, every application transparently will be getting all the logging and metrics collection stuff without even have to implement anything. So it will allow me to do things, it will allow us to reach consistency across services, also like provides us efficiency because now we don't have to implement it again and again. So maybe some of you have noticed over here is here, along with like listener bindings for the services, the application can also specify a pipeline. So it is not only the infrastructure can say that, hey, here is the default flow, do plug in front of the service. I mean, basically, in the configuration, I can define a default pre and post flow, but also allow the application to define a flow at when they configure their service. So Unicomplex will basically will plug a pre-flow, the application flow, and the post flow together and put it in front of the Scoops service. There is like fine-grained configurability over there. You can turn off the defaults, etc., override things. So a lot of configuration available out there. So we discussed about the service boundaries. What should be the right size? Is it too big, too little? And every other microservices article you read, I mean, people talk about it a lot, right? What should be the right size? Is it nano or is it too big, etc.? So, and the other thing we talked about is the joint deployments. So Scoops have something called cubes. I mean, actually, the name Scoops rhymes with cubes. So everyone asks what Scoops, what's a weird name that is. So it means rhymes with the cubes. So a cube is nothing but a jar. But it's just a jar that just has a scoops-meta-conf file. That's it. So cubes are drop-in modules, so they can run in isolation, and they can run together in the same class path as well. So basically, when you build your application, a Scoops application, you build them in terms of cubes. So just to give an example, if I would like to build an application that should be having some payments-related endpoints and some risk-related endpoints, I can build my application in terms of two cubes. One is for payments and one is for risk. And risk one has just the risk-related routes and the corresponding configuration, and the same way the payments cube, right? So I start my application, it serves both payments-related REST endpoints and risk-related endpoints, right? At some point, I realize that, okay, this application is getting quite big. I need to decompose it. So all I need to do now is take the risk jar from the build.spt and just run it by itself, java-jar, run it. So now I have two separate services, basically. So So these two different services are different JVM processes. They even run in different nodes, basically, or different pools. But when I run them together, they are running in the same JVM. They are actually sharing the same actor system, the same Akka actor system. So it basically utilizes all the optimizations of Akka. So when you do joint deployments, you bring two processes together to the same VM, but those two processes are probably competing for the same resource. But with the cubes, they will be using, it's going to be just one single process, and it will be using the same actor system. So it becomes really easy to compose, decompose, and refactor your services, basically. And also, like, performance-wise, you will be, I mean, it's the Akka's suggestion as well, right? You should not be having hundreds of threads out there, right? You should better match the number of cores you have. Of course, there are exceptions, etc., but you should try to keep your thread counts lower, and this basically allows you doing that as well. So cubes are not specifically for routes and all that stuff, but they you can also, like, send messages between the services, between the cubes, and asynchronously. And if you need to move them, separate them out, I mean, you can just in the configuration configure them with Akka rerouting and still keep sending the keep the communication between them. So when you have too many services, so one of the things that we see is that as we discussed, some of the services turn out, I mean, it's not a suggested pattern or anything like that, but that's what we have been seeing. You end up like having some services which basically orchestrates other service calls, right? And also sometimes, like, there are some dependencies between service calls, right? So for that, Scala provides an orchestration DSL. So here it says tasks, so they can be tasks, but I mean, you can think about those as service calls as well. So here, for instance, we would like to run test 1 and test 2 in parallel, and as soon as test 2 is done, run test 4, and as soon as both 1 and 2 is done, run 3, and as soon as both 3 and 4 done, run 5, etc. So when you have such a dependency between operations, I mean, the code gets quite complicated. And I've seen some Java code about that. It says try, catch, exception, and then another try. I mean, it gets quite complicated. The code gets quite complicated. So Scala provides an orchestration DSL for that. So here is how you would be representing this code. So basically, for test 3, for instance, you say that it depends with the pipe operation over there. It depends on test 1 and test 2, basically. So I'm not going to be going much in deep on this, but there is a Scala Bay meetup talk on YouTube. Akara, who's a colleague of mine, has presented, and the entire session is for orchestration. So you can find that on YouTube and watch that. So orchestration basically allows, like, it reduces your code complexity quite a bit, and the error handling, etc., becomes a lot cleaner to represent. You don't have to have all those try, catch, and all that stuff. It simplifies that quite a bit. All right. Other than that, Scala comes with quite a bit more utilities that I haven't covered over here. So I discussed about the request and response pipeline, and so Scala comes up with an HTTP client on top of Spray's HTTP client, but adds the pipeline over there, and also some markdown capabilities. It has an admin console as well, which basically is a pretty JSON representation of all the JMX beans in the JVM. So as an application team, you just need to drop a dependency in your build.spt, and you get pretty JSON representation of your JMX pins. There is a module called actor registry, so which basically allows sending to a or many actors who send messages to other actors based on the request or response type. So you can basically say that, hey, send this message to all actors, which can return me this response, this type of response, basically. We have quite a few stream utilities as well. One of them is a perpetual stream. So from the production, we have some PD teams that basically do a lot of Kafka streaming. For instance, one of the team is doing like consuming from Kafka, writing to Elasticsearch, etc. So some teams have been saying that, hey, I don't want my stream to start until the system state is active, right? So perpetual stream basically integrates with unicomplex lifecycle events, and it basically waits for the system state to be turning to active, and only then starts the stream. Another utility is the persistent buffer. Again, and it basically provides a buffer stage which integrates with the canonical queue. And it was also like, as a result of a request, like, hey, if my downstream services are, downstream connections are like down, I don't want, or actually my service crashes, I don't want to be losing any messages. If I restart, I want my stream to be able to continue where it left off. So, in summary, I mean, moving to microservices is great. I mean, it has tons of benefits, but it's also like difficult. There's a lot of complexity. So whenever you move, I mean, just keep the latency in mind. Right now, the major problem that teams are dealing with is the latency problem. So we have like tons of services out there. I mean, that gets quite difficult to reach to latency. And keep the latency in mind, and I mean, I have fine-grained services, that's fine, but just keep the latency in mind all the time and control your topology accordingly. So Reactive Manifesto is great, build resilient and responsive applications, and standardization becomes really important when you go beyond, like, if your team size goes beyond tens, or like if you have like hundreds of developers, I mean, it becomes especially important. And check out Scoops. You can go to github.com/paypal/Scoops. So all the documentation is out there. We have a Gitter chat link over there. If you click on that, you will be able to join the chat. So we welcome all the negative, positive feedback. I mean, it's very important to us. And if you actually like us, please make sure you give us a star. And you can also like follow us on Twitter with Scoops.